And it gives me amazing pleasure, and it's my honor and privilege to be welcoming you all to the first ever Google Developer Day in India. My name is Prasad and I'll be your host for the day. As you're all aware, Google celebrated its 10th birthday last month, middle of September, and we have a sneak peek into how our journey has been in the last 10 years. So let's look at our Navy to figure out how we've traveled. for developers from all over the world to come together to share ideas and discuss various Google APIs with the Google engineers. And when the 2008 developer days were being planned, we decided to launch the first edition for Google India. Location, Bengaluru. Day and date, Saturday, October 18, 2008. And with that, another first for and in Google India begins, the Google India Developer Day. As you're all aware, Google Developer Day is a free one-day developer forum that focuses on pushing the boundaries of web applications using Google developer technologies. GDDs, as we call them, typically bring together members of the developer community and Google engineers to share knowledge of our products and APIs. This year, our focus is on some exciting innovations in the fields of Opensocial, geo and web applications with sessions on Opensocial, Indic API, Google Maps APIs, Google App Engine and Google Desktop API respectively. Across the world, in around 15 locations, we have hosted tens of thousands of engineers in developer days. Our sessions revolve primarily around our latest developer products, including app engines and Opensocial. We will be talking about new features and versions of the APIs and tools, such as Google Web Toolkit and Indic. We have another AV to take you through the journey of the developer days. Before I introduce our keynote speaker for the day, I'd like to take a couple of minutes to take you through the agenda for the day and also make you familiar with the floor plans of the lobby level and the basement where we are currently. Can we have the agenda please on screen? We will soon begin with the keynote, following which we will have two sessions of the tech talks. Behind your registration pass is a customized agenda that we have shared with each one of you, which tells you about the tech talk tracks that you have been registered for. We have done our best to make sure that your preferences are taken care of, and we're sure we've done a fair amount of justice to it. In case one of the two tech tracks or the code lab sessions that you would be assigned to are not of your preference, please bear with us. We definitely had some logistical issues that we had to take care of as well. We will break for lunch between 11:45 and 1 p.m. People who are attending tech talks in the lobby level will have lunch served right outside the Sigma, and people who will be attending tech tracks in the basement, that's in Esquire halls, will be served lunch right outside where we're seated. Post lunch we'll have two sessions of code labs, and following which we will wind up between 5:30 and 6:30 with some high tea and entertainment. Can we move on to the floor plans please? This again is printed behind each of the registration passes, and then you will have the Google volunteers either in a Google Developer Day gray t-shirt or the black Google t-shirts, or in blue shirts like I'm wearing, who will be more than happy to assist you with whatever your requirements are. Thank you. Without much ado, let me have the privilege again of introducing our very distinguished keynote speaker for the day. It's an honor again to present to you Dr. Prasad Ram, Engineering and Site Director for Google R&D Bangalore. As the Center Head and Director for R&D for Google India, Dr. Ram is responsible for development of Google Search, Ads and Community Technologies. Prasad was previously the CTO of Yahoo India, where he provided strategic direction, developed key search technologies, and oversaw the launch of a number of internet consumer products. Prasad started his career as a researcher at Xerox PARC, where he led the research on digital rights management technology. He received his BTech in computer science and engineering from IIT Bombay in 1987, post which he went to complete a PhD in computer science from the University of California, Los Angeles. Outside his professional life, Prasad has traveled extensively across Indian villages to gain insight into the lives and needs of rural India. A few years ago, Being unhappy with the quality of education provided at the schools in Bangalore, Prasad led the creation of PSBB Academy, a kindergarten to 12th standard school. I invite Prasad to deliver the keynote for the day.
Hi, good morning everybody. So it's thank you very much for taking the time off on a Saturday morning to come. So while most of your friends are still in bed, I'm really happy to see you guys here. And particularly considering that India is playing its cricket match against Australia, and our main batting lineup, Ishant Sharma, Harbhajan and Zahir Khan are yet to come. I think this is a spectacular achievement that you guys have made it out here. And for those of you who spent a lot of time late last night watching the Anand versus Kramnik match, how many of you watched the match? Raise your hands even if you didn't. It's a cool thing to do. So for those of you who spent time, I'm glad you woke up early enough to come. So by the way, Anand creamed Kramnik yesterday. So he's up 2 points to 1 now. So we'll kind of start the day today with an overview of all the things that Google has done, since we build a lot of web applications which are targeted at our users, and we face many of the same challenges that you have encountered. And the approach Google has taken with this is to kind of build out the infrastructure and the technology that's necessary to make sure that our engineers can build faster web applications, more interactive applications, richer functionality in these applications. And what we are going to do today, and what today is all about, is to share a lot of these technologies that we have built and committed to open source with many of you. So my presentation will focus on giving you an overview of the many different things that Google has been doing, and then subsequently the tech tracks and the code labs will cover a few of the specific areas in depth. So I have with me Jagjit Singh, who will drive some of the demos and talk through some of the demos, and I will kind of largely focus on the presentation. Does this work? Yeah. Should we go ahead? Not yet. Okay. Okay. So just to kind of set the context here, you know, the computing world has gone through 3 major cycles. First, we started with the mainframe, where computation and storage were relatively, for the times, you know, very abundantly available. Since there was a lot of computation, these mainframes were, you know, for those times, supercomputers of their times, and there was abundant storage by those day standards. Clearly, what was lacking then was the accessibility of these applications. So if you were a developer and trying to build applications and make your applications and reach out to users through these applications, it was pretty hard to achieve that. But from a user's perspective, ease of deployment was very high. All you needed was a dumb terminal, and then you could access the mainframe. But the functionality was limited, since you pretty much had a text-based interface for the most part. So with the advance to personal computers, we kind of essentially flipped the whole thing. What we saw was computation and storage fell because you were limited to your own PC, but accessibility was very high. All of a sudden, you were able to kind of get a variety of applications running on your PC that kind of gave you rich interactivity, good functionality, quick response times, and so on. And similarly, on the usability aspect, the ease of deployment kind of fell because now you had to install, configure, and kind of manage your whole set of apps yourself, but the functionality kind of became richer. Now, internet kind of began to flip the advantages of these 4 dimensions again. So again, the computation and storage went up. Everything is in the cloud. You get as much storage as you want, pretty much, and the access to computation is very high. But again, accessibility, you know, if you had to build an application and launch it on any one of these, it is a challenge. Similarly, with respect to ease of deployment, all you needed was a browser now. all you need now is a browser. You don't need to kind of worry about installations and upgrades and things of that nature. But the functionality kind of dropped because the applications had limited ability to interact with the end user. So the challenge that Google has right now is to kind of see if we can break the sinusoidal function that we are seeing with these 4 functions, right? So what we want to see is, can we improve the accessibility? So clearly the computation and storage is high. So can we kind of flip the accessibility and make the cloud more accessible, which means allow a lot of people to build a lot of applications and interact, reach out to users through that. And can we improve the functionality? So if your client is a browser, how can we kind of provide you the same level of functionality that you would otherwise experience on the desktop? So making the cloud more accessible and making the client more powerful kind of inherently requires that we maintain connectivity. So these are the 3 big things that Google has been focusing on, is how do we make the cloud more accessible, how do we keep the connectivity pervasive, and how do we make the clients more powerful. So before I kind of delve into the specific technologies that we have that address this issue, since it kind of is important for us to recall that Google was born on the web. Since unlike many other software companies, Google founders kind of owe a great debt to the web, because all of their technologies they leveraged, in creating their technologies, they leveraged the open source tremendously. And subsequently, even as the company has grown, our relationship with the web and the contributions by developers around the world to the web as a platform has been substantial. And as a company, our culture kind of also is one of building consensus. It's about all of us getting together, making great things happen so that everyone else can benefit, as opposed to kind of building a wall around it and making sure that somehow we derive a particular advantage by keeping it close to ourselves. So what is the rationale? So why should we do all this? And since I get asked this question almost every time I talk to anybody, whether it's the user group or the developer group, saying, so it just doesn't make sense, why do you give away all these applications free to users? Or why do you invest huge amounts in Android or Chrome and all these good stuff and then open source the whole stuff? So our philosophy is pretty simple. Since we kind of want to see an open web platform which is extremely rich and accessible to everybody in the world, not just to Google. Once we have such a platform, then richer web applications will get built, more users will come online, there will be greater usage that happens, and then revenue follows from users and usage. So it's a business philosophy that is counterintuitive to the way people thought of software in the earlier 2 eras of mainframe and PC, but makes absolute sense in the web era, where if we can together work to create the best web platform, then each of the developers here who may represent a startup or large companies can go build better applications and serve their users better, increase the usage from their users, and monetize that stuff. Since it's kind of makes sense when you look at it this way, that if we can all work together to create the greatest web platform, then all of us will win. It's not like one company's win has to come at the expense of another company. So that's kind of what is driving us, and clearly we have, in the past 10 years of our journey, kind of shown that this philosophy works, this approach works, and today we are hoping that more of you will kind of join on in this journey with us. So what are the key issues that we need to deal with if we have to address the challenges of developing the web platform? So clearly a lot of the challenges with scalability, storage, since once you start building an application and you have a few initial users, that's great. Like the video on Google's history showed, we started with some 10,000 web searches per day, and the infrastructure required to support 10,000 web searches per day to 10 million or billion or whatever the numbers are is dramatically different. So kind of addressing the issues of scalability, storage, distribution, these are some of the big challenges that we need to address with the infrastructure that we create. So much of this talk will focus on these three things. Client, how do we make the client more powerful? Cloud, how do we make the cloud more accessible? And connectivity, how do we keep it pervasive? Okay. So very recently, and all of you here are certainly familiar with our launch of a browser called Chrome. And the attractiveness about this browser kind of requires you to reflect back on how internet started several years ago, the commercial internet. So the fact that now the browser has become the client. So people kind of were used to accessing applications through rich, thick clients, and now the browser has become the client. So which means what are the challenges that we need to address to make the browser behave or serve the user to the fullest extent that thick clients were, that we are used to with thick clients. So what we do see is things have come a long way. You know, from 1995, there's a screenshot of Amazon.com's web page to Google Street View with maps. The web has evolved. The kind of applications that we are seeing that the consumers get to use has improved dramatically, but we still have quite a distance to go. And okay, so despite all the technology improvements that we have made, going from HTML to DOM, CSS, and Ajax and so forth, the gap between where the browser, the experience of a user using browser as a client versus using a thick client still exists. Since the kind of functionality, the interactivity that thick clients give, the kind of performance that we are used to with thick clients, the access to local PC utilities like storage or printing and things of that nature, all of these are areas that we still have a gap to bridge. So the whole idea with whole idea for Google was to build a browser from the ground up. Since we didn't want to kind of leverage anything that previously existed, because all the traditional thinking around browser was how do we render web pages. Then that was the history of the web to start with. And there were a lot of HTML pages, and how do you render HTML pages? And people kept tacking on newer and newer capabilities into the browser. But what we increasingly see is people are running applications and using these as front end for applications. So if we have to do that, then what kind of security requirements exist for such a client? What kind of stability requirements exist for such a client? What kind of speed requirements exist for such a client? You know, one thing is to render a web page, the other is to kind of run a full-fledged app. So if you think about all the applications that you're running on the web today, whether it's mail or search or Google Docs or any of the other products from other companies, then you'll realize that browser is kind of needs to be much fuller in functionality to be able to kind of deliver the right level of service. So it's a common experience a lot of us have when we have used previous versions of the other browsers in the past, where if one process kind of, one of the applications that we are using and the process associated with that crashes, then the whole browser comes down. And clearly because that, in that generation, browsers were not designed with a model that we can run multiple applications in a multi-process architecture so that we can provide the security and stability required for running these many applications in parallel. So similarly, the whole JavaScript, the introduction of JavaScript kind of changed the level of interactivity that people got used to with the web. But as our reliance on JavaScript continued to increase, the greatest need was to increase the speed of JavaScript. Since oftentimes JavaScript was the bottleneck to better usability, better user experience on the web. So we built the V8 engine, which we kind of have also open source, which is a faster JavaScript engine. And all of this, the entire Chrome was built off of WebKit which is the open framework on which many other browsers have been built. And so with the launch of Chrome, what we show is that we are both leveraging the open source community as it exists and in terms of WebKit, as well as contributing to it. So Chromium is our open source contribution where people can go and further improve upon Chrome, leverage aspects about Chrome that they want to use within their applications and so on. So we'll kind of just take a quick look at some of the features of Chrome that I just described. Jagjit will illustrate that with a demo.
All right. So what I'm going to do here is I'm going to demonstrate the multi-process architecture framework of Google Chrome. So what you see here is Chrome is running with 4 different tabs with 4 different applications: Google Calendar, iGoogle, YouTube, Google News, and some other website open. So if I do a shift escape, the Google Chrome task manager pops up. So generally Windows users are used to using, like, Windows has a task manager for all the processes that are running on the system. Chrome has the task manager for all the web applications that are running in your browser, where you can monitor the memory, CPU, and network usage for all of these. And you might notice that each of the tab has its own row for each of the process, and there is a separate thread to each. So let's say you're working in this news tab and I was somewhere here and something wrong happened with this particular tab. So we would simulate that by saying I will select this news process and I'll kill that. What happens? Snap. Something bad happened. It changes to the bad smiley icon. But then what you see is if you go to the other tabs, you can still interact with the browser. You can still play these videos. It still runs, and you can go to other tabs. You can even, if you go to calendar, you can create the calendar events and stuff. And if I go back to news and I happen to reload this, what you notice is...
I'll be happy to get you up to speed on developing spreadsheet gadgets.
So I'm going to pause this. What happens is Google News comes right back. Perhaps some connectivity issues. Anyway, so Google News will probably come right back and the bad tab will be restored and you will be up and running again. So another thing you need to notice here is that each of the plugin, as the tabs have a process, each of the plugin also have a process. So in this case, the YouTube stuff is having a Shockwave plugin which is running. And if something bad happens in this, interestingly, the first one we look at is the Geolocation Api. What it does is it gives you access to the location of the user by a simple JavaScript call from your browser. Think of the power of this information. Once you have the location of the user, you can provide several location-based services. Say if I am on a mobile client and I say give me all Chinese restaurants near me, you can just take a maps layer and stick stuff over it because I already know the user's lat long. And Google Maps API supports search based on lat longs. So I'm going to do a small demo of the Geolocation API, which is a simple JavaScript call. If you, right now it's determining and it says your location is Bangalore, Karnataka, and this is the lat long. On your local database, you can just launch them off your local database without having to worry about connectivity, and I'll demonstrate that right here. So if I say Google Developer Day, so you see the last 3 phrases are actually stored right here, but this could actually be a web application storing it somewhere on the web. So what I'm going to do is I'm going to copy this URL and kill this tab. Now I'm going to close this tab, and then I'm going to paste this URL right here, and you'll see when it comes right back, it fetches stuff from the local database and displays it back to you. This is the power of offline access, which any of your web application can leverage on.
Terrific. So moving on, so just to kind of remind you, the 3 big things that we said we would address here. One is how do you make the client more powerful? How do you make the cloud more accessible? Which means more and more people can build a whole variety of applications. These applications can interact in the cloud so that they can in turn provide rich functionality to the user. And third was about making connectivity pervasive. So we just talked about Chrome and Gears. Gears is a plugin that gets shipped with Chrome, but there's a plugin that also works with Firefox as well as Internet Explorer. So what we'll do next is to kind of look at how do we make the cloud more pervasive, cloud more accessible, I'm sorry. So, so one of the big challenges all of us have as developers when we start thinking about building an application is very soon we run into the situation that we need vast amounts of storage, vast amounts of computation and so forth. So it becomes a big burden for us to kind of make the investments in all of that stuff before even we know if the application has good user adoption or not. So, and a lot of the popular websites or web applications that you see, whether it's eBay or Amazon and so forth, they can afford to put up large amount of infrastructure. But if you are looking at how do you kind of bootstrap an entire community to come out and generate new applications, then providing access to data centers and massive computing in a way that does not require people to make these big investments is one of the key elements here. So the other aspect is once we have all these applications or whatever applications we have online, the question is, so how do you exchange data with the application and interact with the application and integrate better with the application? So we have the Google Data API, which allows you to kind of read and write into Google applications in this kind of an illustration of this picture. So you can, your web app can actually access a calendar data from the calendar, kind of using the AtomPub protocol, get that information in XML, and kind of use that XML as part of that XML data as part of your application. The other more popular version of the API is the Ajax Api, where you can actually get content out of any of these applications and embed it as part of your application. Like Jagjit showed, you could embed YouTube videos in your blogs, for instance. So that is something that is made possible because of the Ajax APIs that we have. So what we have seen is a significant growth in the API traffic. In this pretty ambiguous chart without labels on the x-axis and y-axis, but what I'm trying to illustrate here is the tremendous adoption of the APIs that Google has launched from the developer community. And today we have over 1 billion daily hits on the API server. So a more recent thing that we did, which I'll kind of spend some time to explain what it is the launch of the App Engine. Now, if we kind of recall the point I made earlier, if you have to build an application and you have to start from scratch today, then it's a fairly laborious process, since you kind of have to get familiar with the LAMP stack. You have to kind of start configuring the Linux, start configuring the Apache server, start configuring MySQL databases and so forth. So just the inertia or the kind of the threshold that you need to rise to be able to create the application to start with is pretty high today. And what Google App Engine kind of aims to achieve is make it very, very simple, where you can write the application on your client using an SDK, test it, and if it all works, then upload it to Google, right? And we handle everything else for you. So Google App Engine is a fully integrated application environment. So you can write your application in Python or Java. And in the current release, which is called the preview release, we up to 5 million page views, you don't have to pay anything. So in effect, you can actually build an application, launch it on Google, and once you actually see people adopting your application, only then you need to deal with the economics of providing the application. But to actually get you started, you don't have to deal with that. So what Google App Engine does is kind of eliminates the need for you to deal with the LAMP stack that I've initially mentioned. And once you kind of actually get the application going, then you have to start dealing with the issues of, so how do I build the monitoring process? How do I do the logging? How do I do reporting? How do I get the machines that I need to run these applications? So we completely eliminate all of these considerations from your application development. So you can stay focused on what is the user need, what is the application function that I need to implement, and kind of leave everything else to Google. So particularly what happens after, let's say you get past the first two steps, you figure out the LAMP stack, you get your application done, you even kind of labor through the whole process of getting the logging, reporting, machines and all that stuff, is when you actually hit success and the transaction volumes go up, then site starts crashing because it's unable to handle. You need database in distributed locations. You need to shard your data. You need machines in different regions, so that you need some level of fault tolerance in the whole system, right? So again, what Google App Engine allows you to do is to not have to deal with any of these issues. Once you put up the application based on Google App Engine APIs, once you have built the application using the Google App Engine APIs, then and you get your application to run off of the Google services, then essentially you can let Google handle all the other issues related to whether it's monitoring, logging, machines kind of issues, or dealing with scale, which will arise if the application turns out to be successful. So here are a couple of examples. There's Wordly.net, which is a site that was built where it takes a web page, for instance, or a website, and kind of essentially gives you the map of the website with what are the keywords in the site and which is the more frequently occurring words, and so on and so forth. So this whole application was built in a matter of few hours and deployed on Google App Engine. Similarly, another application called Playing Now. Here this is an application that runs on iPhones that was created to where one could kind of look at all the movie listings, get the ratings of the movie, look at previews of the movie, as well as kind of do an e-commerce transaction to purchase tickets and so forth. So this application was built. It runs off of Google App Engine, but it's also one of the most popular, or in the top 20 popular free apps on App Store. So now we switch to Indic. Here is the challenge for a lot of the people here in this room is, I'm giving my talk in English, and all of you are probably more familiar with English than any other language. But as it turns out, good 90% plus of Indians are proficient only in one of the Indic languages. So there's 10% or less amongst us who are English proficient. But since we dominate, since we move around amongst ourselves, since we dominate the academic institutes, since we dominate the workplace and so forth, there is a belief that India speaks English. But statistically, based on census in 2001, there's about 90% plus who speak only Indic languages, right? So if you look at what we set out to do is to kind of address the issues that developers have to deal with in reaching out to users who are Indic proficient. So one of the first technologies was, we are all stuck with English keyboards for the most part. So how do you kind of use transliteration to input information that using an English keyboard that is phonetically similar to the Hindi script that or whichever language, Indic language that you are choosing to compose it in, and get the system to automatically transliterate. So take the English script that you provided of a phonetically equivalent Indic sentence and give you the Indic language version of it. So this is the first technology that we implemented, and we'll do a quick demo of that, and then I'll kind of talk about the APIs.
So what we see here is this stuff is launched already on Google Labs, labs.co.in. And what I'm probably going to do here is I'm going to type keystrokes in English, and I'm going to get Hindi text. And you see I made a mistake, so you can go correct. So what you see here is Hindi text coming by English keystrokes, and this is and you can even give different suggestions to this thing. And it's a pretty smart machine learning algorithm, as in when you keep suggesting spellings and more people say this is the right spelling, we will run over time, and as we get more usage for this tool, the transliteration quality will improve. So we'll switch back.
So we kind of first implemented transliteration as a technology And because India has not one language but 22 official languages, and most people in other parts of the world don't understand how can a country have 22 official languages, but nevertheless we do. So we couldn't kind of implement it in some rules-based manner which would work for one language or two languages. We had to do it in a way that using machine learning so that the system can be subsequently trained with other language pairs and English with other languages, and it can learn other language transliteration in other languages. So once we did that and we kind of launched it on Labs and then incorporated it into a variety of Google products. So you can go to Blogger and blog in Hindi. You can go to Orkut and scrap in Hindi or any of the other 8 main Indian languages. We also kind of recently launched the Transliteration API. So Transliteration API allows other people to take advantage, other developers to take advantage of the transliteration technology that we have created and continue to invest in. So here is an example where Facebook essentially kind of leveraged the transliteration technology to provide Indic language interface input mechanisms into their application. Wordpress, another blogging tool which kind of also uses Google Transliteration API. And we most recently kind of implemented a Firefox plugin. So if a user kind of installs the plugin in their Firefox, then literally any form where you need to enter text in the web page, you can start inputting text in Indic languages. So basically with this, what we have achieved is, number one, make sure the technology is good. Make sure we eat this, in Google we use this expression of eat our own dog food kind of a thing. So we use the same technology and then make it available for rest of the development community to kind of leverage and access it. So I'll briefly talk about maps. Google Maps has been one of the most important forms of organizing information. Since you can organize information, the way we do it with the search, where we have a, ranked listing of search results. But Maps kind of provides a very interesting way where you can visualize the information on a Maps layer. So Maps APIs have been popular for a while. So for example, if you are trying to find an apartment, then you can go to a real estate website where you can search for the apartment, identify the neighborhood where you want your apartment, where you want to get your apartment, kind of visualize the whole thing on Maps. Then you can kind of look at another site where, given that neighborhood, it kind of shows you how safe it is. So it kind of takes the crime related data and overlays it on Maps so that one can kind of visualize the, get a mapped view of how safe different neighborhoods are. And you can kind of, if you have kids and you're also looking at which schools you want to send or what are the good schools in this neighborhood and so on, you can kind of overlay that information with Maps and make that decision. So you can pick a neighborhood, look at the apartment, the prices and information that a typical real estate website would give, but also combine it with the crime information or the school information about that neighborhood before you make a decision to buy. One of the best examples of using the Maps API is a product that we launched recently called MapMaker. So this is a product where the creator of the product was inspired by the situation in India, saying we don't have good maps. Now many of you will argue that we don't have roads to draw maps, but if we save that piece of, if we leave that alone, then kind of getting good maps is a difficult process in an emerging market like India, because businesses generally don't have the incentive to create maps and maintain the maps. So what, led by an engineer at Google, what the team did was to kind of use the Maps API to create a wiki-based tool and a product so that the whole community could go and map out the piece of information they individually know. So you know the street that you live on, the school that you went to, or the workplace that you go to. And if you can kind of get that information, then the technology underneath it kind of stitches all the data together. So we'll do a quick demo of a couple of features here. but we have a longer session on maps in the tech track and code lab where you will kind of see the rest.
So what I'm going to show here is we will draw, say, a feature like a road on this particular map. You see this road which is not mapped yet, so I'll come here and say draw a line, and I say this line is actually a road. Then you can start drawing here. I draw this length which is 294 meters, and I say okay, I want to draw this road now.
So yeah, let's just talk through it. So basically this is a tool that we will demo in subsequent sessions, but the point that we were trying to illustrate here, if the network worked, was that it's a simple tool where using a satellite image you can actually, a human can visualize the road, kind of mark the road and then provide attributes, and then there's a whole underlying system to make sure that there's no abuses in the process that happens, or the kind of data that gets input depending upon the sensitivity of the data. There's a different level of moderation process that kicks in and so forth.
I think we are live again.
We are live again? Okay,
yeah.
Good. We can continue.
So what you see here is I actually cartographed a piece of line which is actually said it is a road, and I can do rich metadata addition to this particular it's in Karachi, Pakistan, so I say this is Stadium Road. What area is this in? I say cantonment area. And then you can do other attributes to this road. Is this a local road or is this a highway? What surface is this? Is it two-way or there is a one-way restriction on this? What is the speed limit, the number of lanes? Is there a divider? And then I can do other kind of textual description if I want to describe, saying this has way more potholes than the divider. So, and you can save it, and what will happen is this will get baked into the map style and as user generated maps for other users to see. At this point, what I want to do is I want to show you the current map of Lahore with Google Map Maker. What Lahore looks like now is this. You see a number of roads clearly marked. You see some highways marked. You see points of interest like Karachi University, a golf course, Pakistan Air Force Base. But this was not like that a few weeks back. When we launched MapMaker in Pakistan, the map of Karachi was completely blank. Then how did this happen? A short video will demonstrate how this happened. So what this is people drawing different points of interest in Karachi, and this is just a time slice of the same tiles over time, and what you see is users actually cartographing Karachi, and now you are a place where Karachi has fantastic maps. So this is the power of a tool like MapMaker, which is completely built over Maps API, and technically anybody outside Google could have built such a fantastic product using the Maps API.
So this kind of also illustrates some of the situations in developing countries or amongst emerging users where we don't have content for our own region, and here's a wiki based model which we can use to create the content, and such a product was built using Google Maps API. So we'll kind of switch to the third part about how do we keep connectivity pervasive. So one of the things that has happened is, I don't want to kind of state the obvious, that mobile phones have essentially become so pervasive that the number of mobile phones in the world will far outstrip the number of people in the world if the rate of growth continues, right? So but it has created a particular, while it's great from a user perspective, from a basic conversation use of it, but it kind of creates a new problem for the developers. Since there are a variety of different platforms, variety of different stacks that you need to work with. If you have to launch an application on the mobile device, you kind of have to work across many devices, test it across devices, maintain your application as each of the devices kind of version themselves. And not everything is open. Not everything, even if the underlying operating system shares with you certain APIs and so forth, and even if you're willing to labor through it, it's not everything is open, not everything is accessible, so it limits inherently the functionality of your app. So in our effort to kind of keep connectivity pervasive and recognizing that the growth in mobile far outstrips the growth in PCs and so forth, we kind of simplified the whole thing by developing the entire stack all the way from the metal to the applications or some of the rich applications. So we developed the entire stack and we open sourced it through Android. So all of you I'm sure are following the launch of Android and the kind of the availability of SDK and so on and so forth. So once Android SDK becomes available very widely towards in the next few days actually, then we expect a lot of the developers, including many of you here, to start building new applications. So for the first time, you have complete control over the entire software stack that goes on a mobile device. So Android is an open source. We also formed the Open Handset Alliance with about 34 companies in it who have agreed to kind of leverage the Android stack in the devices they do. So our hope here is that we will be able to kind of get the device manufacturers, the operators, the developers to all work together and work off of a common open web platform to build a fantastic set of experiences and applications for the users that we all hope to serve. So we'll kind of show you a short video. So as I mentioned, the Android SDK itself will be made open on 22nd or so of October. So we'll kind of share with you a video that, a clip from the video that we have from the Google I/O conference that happened earlier this year in San Francisco.
So, okay. Switch over to a demo of a device here. So what you see here when I wake up the device is basically an unlock screen. This unlock screen is customizable. So you can basically choose what your unlock pattern is. For example, if you want a simple gesture to unlock your phone, you could do that. I guess that's not the one I use this time. Or you can have a more secure pattern. So in this case, let's say I trace a G, and that'll unlock your device for you. So you can have a very friendly or complex, as secure as you like, unlock gesture for your phone. Additionally, what we have here is the basic home screen for Android. There's a couple things on it, of course, basic stuff like applications that you can launch. It's also got a status bar at the top. The status bar has all the things you would expect. It's got the time, battery life, signal strength, and so on. It also has some icons at the top, notifications that come from other applications. Of course, you see that in other phones as well, where you've got a mail or an SMS message or a calendar that the phone wants to make you aware of. Well, in most phones, you actually kind of have to guess and say, well, where did that come from? What app launched or put that notification in? Well, with Android, you just touch on the status bar and drag it down, and you have access to all notifications, and this is available to you from any application in the system. You don't have to be on the home screen to put on your status bar. Anywhere you're on the device, you click it, and then you can click on my calendar notification here. It'll tell me I have a test at 9 o'clock, and you can dismiss it that way. So you can easily get your missed calls, read email, etc., through the accessible status bar. We also have a home screen here that I mentioned before. It shows you applications that you can launch, various apps I have on the device, some favorites along the bottom. It also has a couple areas on it that you can move around to. So with a simple gesture of your hand, you can fling it around. You've got a Google search box, a clock. You want to move your clock around to customize it, simply drag it over. You can actually customize things any way you like. You can also create shortcuts. Simply by pressing on an empty space here, it brings up a menu. Let's say I wanted to create a shortcut to my favorite browser bookmark. Let's say I want to do the New York Times, and then it creates a New York Times icon here, which is very easy to access for your web browser. You can also create shortcuts to other things. For example, Gmail, music playlist, contacts. For example, if I wanted to have a favorite contact on my desktop here, just simply create it, and then I have simple one-tap access to the contact card for Adam. Not his real number, so don't worry about trying to call him there. So I showed you a little bit about the home screen again. Very simple app launcher. You notice that the icons at the bottom are persistent, so you have your favorites along with all your customized content. We also talked early on about the WebKit and the web browser. So if I go ahead and launch the browser here, it's going to take us to the Google homepage, which is basically something they call Grand Prix. It's basically Google made for mobile devices. It gives you a Google search box, access to your calendar, access to your Gmail, etc. So basically, this app was, WebKit-enabled phones. Didn't have to be modified to run on Android. Very, just works out of the box. So any work you do that is taking advantage of WebKit-enabled phones will work on Android without any modification. Another thing I want to show you on Android is some of the cool zooming technology. So here we have, we'll go to the Google I/O site here. And this is obviously the conference that you're at. You can see the website for it. You can do basic things like flinging the page around. You can also use some zoom stuff. For example, if you double tap, you get a little magnifier. By dragging that magnifier around, pick the part of the page you want to zoom in on, and we can go see Chris DeBona up close and personal there. You can use this to navigate any site that you want to have access to and zoom in on a particular part of the page. Next, I'll show you Google Maps. Again, very important mobile application. We have a 3G network that we're on here, and this device is 3G capable. So you'll notice that with 3G capable networks, you have very quick, easy access to all the Google Maps data. You can switch map modes here, for example. We can go to satellite view, and you can watch all the tiles load in at 3G speeds. And you can imagine what your apps are going to be able to do when they build themselves on top of GMM with 3G network. Pretty impressive and powerful things. And then another app that I want to show you really quick is, you've probably heard about our developer conference, developer challenge, where we sponsored an event to get all kinds of entries. We've had just huge interest in that. We've seen a lot of different entries, and actually the thing I'm going to show you was not even an entry in the contest, but rather was done by our friends at Namco. Quick little diversion. One of my favorite classic games here, Pac-Man. Go ahead and start up a new game. Got some time to kill, so you guys have nothing else to do, right? So you can watch me play Pac-Man for a couple minutes. So here we go. Unfortunately, the sound isn't coming across real well here, but it's got all the favorite beeps, and it actually vibrates when you die, so it reminds you that you got eaten by a monster. Lastly, what I want to show you is some actually, newer technology, something like Street View here. You've probably seen Street View in the past. Basically the technology that we have in here, which uses the Street View tiles that come in from the web. With a flick of your finger, you can easily navigate around. But one of my favorite new features on Street View is the ability to use the built-in compass in this device. Switch on to compass mode. And then you can see that this device will actually track my movements. So you don't even have to lift a finger. So that's it. Just wanted to give you a taste of some of the cool things coming for Android, and we can't wait to see the kind of applications that you'll build for the platform. Thanks very much. What to do now is switch over to a demo of a device here.
Okay. So that was Android, and as I mentioned, in the next few days we'll have access to the SDK, and we look forward to all of you kind of getting on top of it and start building out great apps. So one of the other things that we have most recently done or have been using consistently within Google is the Google Web Toolkit. So the idea here is that if we kind of want to build very, very rich experiences for the user, like I mentioned to you, from a client perspective, if we kind of want to give the user the same level of experience that they're used to from thick clients, then trying to do all of that coding in JavaScript itself makes it a pain. So we have built this cross-compiler that allows people to write the software in Java and cross-compiles to JavaScript that works across a variety of browsers. So the best way to do this is to kind of illustrate one application that has been built in Java but works in your browser, as if you would assume, looking at it, you would think that it kind of must be using Flash and this and that, all this other cool stuff, but actually it's purely a Java application that has been cross-compiled, and what you're seeing is JavaScript performance.
So what I'm going to show here is an application called Lombardi Blueprint. It's actually just a diagramming tool. And when you see this demo, just keep in mind it is an actual pure web application built over GWT, and it's complete HTML, CSS, JavaScript with no Flash at all. So what all do you expect to do in a diagramming tool? Let me launch that application. So the idea is, using GWT, you can build very fancier and very powerful Ajax applications, which will be demonstrated with this demo. So typically what all would you do with a diagramming tool? You would probably be able to do edit inline, and then you should be able to say I'm going to move things around so that my graph changes, so it animates. I can go into a detailed view of one particular process and change things right here, or I can even do a Control Z to move things back, and I can go to a different view, say a process diagram, with the ability to zoom in or zoom out from this. And think of it, there is no flash around here. It's all completely HTML, CSS, JavaScript. At this point, I want to talk about another thing which GWT provides is the hosted mode. What hosted mode does is you can write your application in your favorite IDE, which is in case for Java could be Eclipse or NetBeans or whatever you are comfortable with, and hook up that code to the hosted server, which will run bytecode live in a local server running right here. So what I'm going to do is I'm going to start that server and bring up an application which is the sample application shipped with GWT, in this case a mail application. So the application is going to come up, and what you see here is an application running in a hosted mode, and it's actually an instance of the browser. In this case it's actually taking out Firefox shell and then running into it. What it really So what you see here is an Ajax Api application built completely using GWT, and the code for this is completely written in Java. So you see you can interact with it. It's a fully functional mail application. It works with all these tabs. So what I want to show you now is I hooked up this code in Eclipse, and you see all this code is written in Java, and what you do is I'm going to show a quick demo. You see these tabs of mail, tasks, and contacts. I'm going to go to shortcuts.java, and I am going to change some of this stuff. So for that matter, if I make this mail as my mail and this as my task, and I change it as several contacts, and I just happen to save the code, which is a Java code. So what this guy does is this hosted mode will run this bytecode right here. What I just need to do is just say refresh, and what you see is whatever changes I made are live. So what you don't need to do is compile your application into jar files, apply to a particular web application server, and then worry about did it come out correctly or not. And if you worked on Ajax, you would know typical debugging of these problems is very, very complex. Advantages, I'm writing in my own IDE, I'm writing in my language of my own choice. I'm really worrying about the cool features which I'm wanting to provide in my application rather than the browser quirks and cross-border compatibility. At this point we'll go back.
Okay. So again the key message here is that you will be able to use the idea of your choice. You will be able to kind of write all of your code in Java and still kind of get the functionality as if you have a rich thick client on the user. The user has a rich thick client, but the user is actually using or interacting with the application through a browser. So finally, I'll kind of briefly touch on Opensocial. Since we all are very familiar that we have all come to recognize that web is a social environment. All of us interact a lot, and there are a number of products that have resulted in creating a large number of social networks on the web. So what Opensocial is a family of APIs. It kind of allows developers to interact with the users or access the users and access the information available through the social networks. And it's again, very typical fashion to the web. Number of us have agreed to a common set of APIs, and each of the underlying container, whether it is MySpace or Orkut or Hi-Fi or whatever the social network is, kind of implements the APIs, and we are able to kind of allow the developers to access about 350 million users who are the sum total of all the users across these different networks. So we are able to kind of number one, make it simple for the developers to reach out to the 350 million users, simple for people who are coming up with newer social networks like Hives and Netlog in this case, which got launched in October. So the 40 million users that they serve can access all the applications that were previously built on using Opensocial APIs. So we are able to kind of bring to the developers the complete reach of all the social networks through a single application that they build and deployed across these different social networks. So in addition to kind of specifying and agreeing upon the APIs, one of the things that a number of the companies kind of got together and created the opensocial.org or the Opensocial Foundation, and which kind of continues to maintain the specification of the APIs. And very recently there has been the whole shindig reference implementation of these APIs, so that if you want to kind of if you are a company that owns a social network or that has a product that attracts a social network, then the reference implementation of these APIs are available, and you can start with that and make minor tweaks to make it work for you. So essentially, whether you are a developer building a social application that leverages the social networks, or you are a developer or a company that owns a social network, we have through Opensocial initiative, what we have managed to contribute is to make it simple for you to build applications, to provide rich user functionality, as well as make it simple for the network owners to kind of give their users complete access to all the applications that the developers have been creating. So clearly many of you are here who own Hangama or Chakpak and Minglebox and so forth. So number of Indian developers have kind of caught on to the Opensocial APIs, and there's a significant volume of new applications that are coming out every day, and it's dominated by Indian development community here. So with that, I kind of want to reiterate that our initiative here is to kind of achieve the three things: make the client very, very strong, very functionally very strong, make the cloud very accessible so that anybody can build an application and anybody can interact with the other applications on the web, and make the connectivity pervasive so that if you are on the mobile device, you're always online and you can access all of these applications. So what we hope to see happen the rest of the day here is we'll have sessions that go deeper into each of these areas, kind of through tech talks as well as code labs, and you can interact with the speakers there to get to the next level of detail on each of these. And I'm hopeful that you will not only kind of learn a lot during this day here, but you'll also kind of enjoy interacting amongst yourself, and we will kind of continue to meet again every year, hopefully, given that this is the first year of the Google Developers Day in India. I look forward to kind of interacting with all of you again next year, where we will have a lot more local stories to share, a lot more local applications to showcase, a lot more infrastructure that each of us would have created from our respective companies but contributed to the open source pool. Thank you very much. I want to kind of also thank my colleague Jagjit, who drove all the demos for us. I sincerely appreciate you taking the time to be here on a Saturday morning. Have a good one.
Ram, thank you. Thank you for setting the right tone for the rest of the day. We will have the agenda up on screen again. Thank you. As we move into our first session of the Tech Talks, I would request all of you to look at the agenda again, and also which is printed behind the registration badge. Just for the benefit of everyone, we will have the Google Desktop API and the Google App Engine talks at the lobby level in Sigma 1 and 2. And we will have the Indic API up here in the Grand Ballroom, and Opensocial Esquire 1, Maps API Esquire 2 just across the corridor. Have a good rest of the day, and we will all meet here again at about 5:30 for a wrap-up.